Right, question 16. It's the transport equation. I equals NAVE, or NAVE, which is the best way of remembering it. Right, there's a nice diagram there. State what each of the terms NA and E represent. Okay, right. N is the charge carrier density. In this case, the charge carriers are electrons, but they could be positive ions in a solution. But yeah, charge carrier density. Yeah, which is the number of charge carriers per unit volume. Okay, matter density is the mass per unit volume, but this is the charge carrier density. Literally, how many charge carriers there are per meter cubed. So, because numbers of things in physics do not have a unit, like the numbers of electrons, or the numbers of stars, or the numbers of anything, because they're just a number, the number per unit per meter cubed means that the unit is per meter cubed. So this is the charge carrier density. A, okay, charge carrier. A is the cross-sectional area. Don't say area, please, because that could, surface area? Okay, it's the cross-sectional area, and of course that is meter squared. And E is the charge on a single electron, which is coulombs. Okay? Right, the cylindrical copper got a diameter of 0.58, carries a current of that. We've got the number of electrons per cubic meter, so that's our N value. Right, we've got the diameter. So we're going to use the transport equation, which is given to us at the start of the question, which is nice. Right, so we've got, diameter is 0.58. 0.58 times 10 to the minus 3. I'm going to leave it like that because my calculator does not care. Right, there you go. What's the radius though? So the radius is half of that, which is 0.29 times 10 to the minus 3 meters. Okay? Right. Cross-sectional area is still pi r squared. Hasn't changed. And that comes out as 2.64 times 10 to the minus 7 meters squared. Okay? Right, drift. So we've got that. So we've got the drift velocity. We need the drift velocity, don't we? So we're just going to plug in some values now into the equation. We've got the current is 1.31, so I equals nave. N is this one here, 8.49 times 10 to the 28. A is the thing we've just calculated. V is what we need, and E is 1.6 times 10 to the minus 19 because they are electrons. That gives us a drift velocity of 3.65. 3.65 times 10 to the minus 4 meters per second. Right, try and get to the habit, guys. Look at your numbers. If you come up with something stupidly fast, you've messed up the calculation. All right? Always look at values. You should all know that's why it's called drift velocity, because electrons actually move very slowly. They kind of meander through a conductor. So your value of drift velocity should be slow. Look at the value you write down and think, should it be fast? Should it be slow? Is it fast or is it slow? Okay, it's a really, really, really important habit to get into. Okay, well, we've now got two sections of conductor, two sections of different copper wire. Okay, right. Each wire, however, is made from the same copper and they're the same length. Right, describe how quantities I, N, and V compare. Very similar to one of the multiple choice, this one, okay? But you should know, if it's the same material, then N is the same, okay? N in that is the same as N in that. Now, if they're two conductors, okay, or two things in a circuit, it could be a superconductor and a piece of plastic. The current will be the same, okay? So I is the same, okay? But it's asking us to describe and explain. So N is the same because same material or same copper. I is the same because they are both in series. That's what gets you the marks here. Okay? Now, what's going to happen to V? Well, V might be different, or V will be different. Now, we figure out how different from the equation. Right. I equals N A V E. Okay. I's the same. N's the same. E's the same. They have to be constant for both conductors, A and B. Right. In A, okay, so for area, let's have a look. I don't remember. The cross-sectional area of A, okay, the cross-sectional area of A is less than the cross-sectional area of B, isn't it? Okay, so to maintain the integrity of this equation, the drift velocity must be greater in A. Okay, so if this one is big, this one must be small. If this one is small, this one must be big. Yeah, A and V are inversely proportional to each other because I, N, and E are constants. So, how does the value of V compare? All right, so the velocity in A is greater than the velocity of B because the area of A is less than the area of B. Seems like that right, didn't I? Yes.